for General Motors. From China to Michigan, New York to India, this man is in charge of technological advancements for GM. Please welcome to the stage GM Global Research and Development Vice President of General Motors, Alan Tao.
Well, it's really an honor for me and General Motors to be one of the main hosts for ITS this year. And if you're expecting me to start dancing and turn around on my head, I think you're all going to be disappointed for the next. I think it's pretty clear that we are in the midst of a revolution in our product, and some of the exhibits see this edge of technology. And the question you have to ask is, this decade so different for the industry in general, for the governments of the world, and it really boils down to the fact that the automotive industry, which for a century first invented and then proliferated personal mobility, defined as personal ownership of a vehicle, is now a victim of its own success. Why? Because we have made an extremely robust product that is remarkably affordable. And in fact, every year, more and more of the world's population can afford to own a vehicle. And the world's population is growing. We are at the point where we're looking at a world with over 1 billion vehicles in operation. And the challenge which we need to take on is to reinvent that vehicle, because the product that was invented 100 years ago and that we've refined dramatically for a century cannot be the answer for a 1 billion, a 1.2 billion, a 1.4 billion vehicle car park. And I'm really pleased to hear that there's potentially 8,000 registrants to this conference, representing more than 100,000 researchers and engineers around the world that are helping us to take on the challenge of reinventing the vehicle. As we look at the growth of the vehicle car park, we really see 5 challenges against the sustainability of personal mobility as we've come to know it. First, and I think everybody recognizes this around the world, the days of us being 96% reliant on a single energy source for our fleet, petroleum, need to end. We have to diversify our energy source, and we need to take the tailpipe out of the environmental debate. At this point, there is less than 1% of the emissions of a tailpipe that there were as recently as 30 years ago. And yet every year the regulations keep increasing and increasing. The fact is, a vehicle running around in Los Angeles today with the latest after-treatment technology, as measured in NOx and SOx, the air coming out of the tailpipe is cleaner than the air going into the engine. And yet every year we need to become cleaner. So as we look at taking on these challenges, the roadmap for the propulsion system for the automobile for the 21st century has been laid out. We need to diversify our energy sources. We need to improve the efficiency of the internal combustion engine, but the end game is the electrification of the vehicle. And there's various elements of that that you'll see in the talks and the demonstrations this week. What's enabling it is, in fact, 2 breakthroughs in technology. First, the lithium-ion battery, which is dramatically increasing the energy capacity of batteries on a vehicle. And second, the improvements in the technology of hydrogen fuel cell stacks and storage. Both of these allow us to move vehicles by electrons powering motors. And in fact, in both cases, the technologies are ready for commercialization. Each has its own place in the marketplace. With a fuel cell, we have some challenges remaining on cost, but it gives you full range. On the batteries, we have both a cost challenge, but more importantly, we still need some breakthroughs in battery energy density. And one thing we did to overcome that in the Chevrolet Volt, which we have out for display this week, is augment the battery with an onboard recharger. That doesn't mean that pure battery electric vehicles are not ready. There will be applications in the marketplace where limited range electric vehicles make sense, particularly in urban environments, and we just announced that we will be marketing in California and other select markets an electric version of our Mini Cooper, the Chevrolet Spark. But if you look at the topics of this Congress, historically, it's been around what I call the electronification of the vehicle, and in particular, making vehicles that are safer. If you look at what has happened since the publication of Unsafe at Any Speed, we have done tremendous engineering improvements to protect the occupant in the case of a crash, and those technology improvements continue. We just announced the introduction of now a center airbag in our midsize crossovers that really can add additional protection, particularly in the case of a side impact. But the era of protecting occupants in case of a crash is starting to meet diminishing returns. At the other end of the spectrum, particularly for the past decade, we and others in the industry have been working hard at getting aid to the occupants in case there's a crash. But all of that effort will become moot as we march towards vehicles that do not crash in the first place. That journey began with the introduction of anti-lock brakes, and it's continued in a pretty high momentum of the introduction of more and more capabilities on the vehicle to avoid a crash. And this is not something imaginary. General Motors and other OEMs, and you'll see many examples of this today, are more and more putting features on the vehicle that first warn drivers and then intervene to prevent crashes. And in fact, we're learning how to make that technology more affordable. We just introduced an industry first of a single camera system that at lower cost than other systems enables an imminent crash warning. And that is the beginning of trying to solve one of the technical hurdles for vehicles that don't crash, and that's the cost and availability of sensors. If you look at what it will take to enable vehicles that do not crash, we need to provide 360-degree situational awareness, and in fact provide it so that the computer on the car has more awareness of what's around it than a typical driver. One of the technologies that will enable that is vehicle-to-vehicle communications, which many OEMs, including us, will be demonstrating in various forms at the conference this week. However, you might read from this slide that the value of vehicle-to-vehicle communications is the reduction of sensors. In fact, that is not going to be the case for some time. It's rarely the augmentation of sensors. Why is that? When vehicles can communicate to